Electric vehicles have been catching fire left and right all over the world. An electric double-decker bus in London erupted into flames following an explosion. Electric vehicles have also been catching fire in Florida after flooding. Even after the EV dries out, the fire risk doesn't go away, as explained by the fire marshal.
The salt water that is flooding can get into the battery and dry there. And once it dries, it creates what federal safety officials call bridges between cells. And that can lead to fires. And those fires can come anywhere from days to weeks later. And once an EV catches on fire, it is incredibly difficult to put it out.
Tesla catches fire randomly while driving in Modesto, California. An electric cement truck catches fire in Melbourne, Australia. This is just to name a few incidents. There's also countless incidents of EV fires and explosions in China, home to the world's biggest electric vehicle seller, BYD. Here, we have an entire row of electric school buses catching on fire in a university campus. Observe how the EV fire spreads from one bus to another as the flames engulf the adjacent vehicles. Thank goodness no one was hurt in this fire. In this video, we will discuss the most critical factor to consider when talking about mainstream EV transition, which is safety. Watch till the end to fully understand why this issue is so concerning, not only in terms of safety, but also considering the time and financial burden associated with resolving EV hazard problems. Before we go on any further, we need to understand why EVs catch fire. There are several possible reasons, but majority of the cases are due to a fault or defect in the battery design. Abuse of one or more battery cells by overheating, overcharging, or as a result of a collision. A fire starts when a damaged or abused battery cell is short-circuited, triggering a chemical reaction that generates toxic and flammable gases and a significant amount of heat. This heat can lead to a chain reaction called thermal runaway. Back in November, just a single faulty lithium-ion battery out of 150 cells in an EV cement truck caused it to be engulfed into flames in Melbourne. So what's the big deal about EV fires? Since internal combustion engine cars catches fire as well, EV fires are probably not much different, right? Wrong. EV fires are much more difficult to put out and deal with. Here's why. Firstly, they don't require any external oxygen from the air. The chemicals in the battery cells provide the oxidant to keep the fire burning. Secondly, the fires burn at a vastly higher temperature than regular petrol or diesel fires, 2,500 degrees Celsius compared to 900 degrees Celsius. Thirdly, they give off a cocktail of lethal gases, which are highly toxic if inhaled. Fourthly, they can spontaneously reignite days, weeks, or even months after they were first extinguished. And finally, fifthly, the water runoff from the scene of the fire is contaminated and considered hazardous waste, which should not be allowed to disappear into stormwater drains or water courses, and should ideally be contained and then removed for proper processing. Let's take a look at a real example of what happens when an EV catches fire. This is the case of an electric Jaguar destroying the garage while charging. I'm very glad to say that there were no injuries sustained and the house involved in this incident did not succumb to the fire, but that was just down to extremely good luck. Lithium-ion battery fires will ignite virtually anything nearby, and so it was really luck that prevented the entire house from going up in smoke. Let's take a look at the video from South Metro Fire Rescue Centennial in Colorado. And the first thing we'll notice is that as soon as an EV is involved, the hazmat team must be deployed. By the way, when you're watching this, see if you can count up how many appliances and personnel were required to deal with just one EV fire. First, the fire rescue pickup truck was used to pull the burning electric vehicle out of the garage and onto the driveway where it was safer and there was lower risk of the house catching fire as well. Then, the firefighters, in their full protective equipment and respiratory safety equipment, applied that blanket. The blanket is needed because once you put out the fire, you can't just leave it because it could catch fire again at any moment. Just consider how many people and appliances are involved in this operation. There must be at least 20 firefighters and at least 4 fire safety vehicles just for one single EV. Those blankets cost anywhere between $3,000 and $5,000. Once the blanket is applied, the scene is relatively safe, but this is far from the end. The entire emergency services then escort these burned-up EVs to the scrapyard on a tow truck covered in this blanket, which is somewhat smoking as they drove down the road with a fire department escort. The fire truck had to escort the tow trucks to make sure that if there was a mishap with the blanket and a fire occurred on the roadway, they would be able to suppress that fire and call additional resources as needed. Once the vehicles are at the salvage yard, they remain underneath that electric fire blanket, which is limiting the oxygen flow to the battery, which is still smoldering. The idea is to prevent a fire from spreading, and it's preventing open burning. And eventually that battery pack will cool down to the point that the fire will just be extinguished. Doesn't this sound ridiculous? The amount of time and money it costed for one EV fire. In this case, everyone was lucky, no one was injured, and the house was saved. But what happens when we're all driving EVs and a line of them are parked up charging in the basement car park of an apartment block, and one of them decides to self-combust like this? Jaguar EV did. Also, this was just a single car. What about electric buses? One can only imagine the magnitude of the situation when a bus with 5 times the number of battery cells with 20 passengers on board burst into flames. In London, an electric bus caught on fire. Here's footage from the Daily Mail, accompanied by their report. Terrified Wimbledon residents reported a massive bang as the double-decker bus burst into flames, causing chaos and filling the streets with black smoke. The dramatic video, obtained by Mail Online, captures firefighters' intense battle against the inferno. Transport for London has initiated a probe into the blaze that ravaged the bus's rear and shattered its back windows. Miraculously, there were no injuries. We should also recall the incident from May 2022, when 2 identical buses caught fire at a Potter's Bar depot in London, leading to a fleet-wide safety check. The fire there was a vivid demonstration of a battery pack experiencing thermal runaway. Diesel buses might catch fire, but they're easier to extinguish with a handheld device. In contrast, the lithium-ion battery in this bus burned so intensely that containment was nearly impossible, as seen in the video where the fire repeatedly reignited despite the dousing efforts. Moreover, the smoke released highly toxic gases like hydrogen fluoride, hydrogen cyanide, and sulfur dioxide, posing significant dangers. The occurrence of these incidents raises the question, are electric vehicles truly worth it? I am not a technophobe who is stuck in her old ways. Neither am I a hater hating on EVs. It just seems like we are rushing things. Before we try to make electric vehicles mainstream, we ought to first of all make sure that the technology is safe. These are my thoughts about the current EV situation. Let everyone know your thoughts in the comments down below. I just uploaded a video about groundbreaking news that could hurt the entire EV industry. Do check it out if you want to be truly shocked by what's about to happen with EVs.